can't see the screen.
Yeah, is it visible?
Yes.
Okay. So uh, just a minute. I will start. Okay. Okay. So I will start. So we are group six. We are Pablo Escobar, and this is our mascot. This we have just given it to bin image that there is a studio Pablo Escobar with books. Just generate us image. So there's who is. We'll be presenting on chapter two, Introduction to Machine Learning System Design. So uh, yeah, and okay. So I'm Smith. I'm senior machine learning engineer at Hitachi. Currently, I'm working on monitoring data. There's my handle. If you can like connect with me, that would be great. Gopi is not with us today. He has some personal work, but he is working as an machine learning intern at Samsung. He's currently working on diffusion models. I think Raghu, if you can go ahead.
Hey, hi, I'm Raghunath. I'm working as a senior software engineer at Pega Systems. So I mostly working with natural language processing with classical machine learning, along with the current GenAI with a RAG-based architecture to help in automating the workflows in the applications. Yeah,
Okay,
that,
and we
that's
had a
it.
couple of other uh, members in the group, but we only got their Discord handle, so we have put a placeholder for them. Yeah. So starting with the presentation, the agenda would be that we'll go over on a short recap of what we got from chapter one, and then we'll be looking at the key takeaways from chapter two with some examples, then some personal opinions on impact of yes, sorry, Chip. Are
Yeah,
you?
I just want to set the context for chapter two. So for the fun
Yeah.
fact, when I was looking at like which chapter, which group want to present, nobody picked chapter two. So I think that chapter two is also like the least technical chapter of the book. But when I was giving talks at companies, especially like executives, they really like chapter two because it's only so a lot of people have told me that like they have a lot of teams who are very smart, very excited, but they don't think about machine learning from a business perspective. And so it's very important for a lot of companies to have like engineers to think about, okay, this is a cool solution, this is a cool algorithm, but how does that impact the business bottom line? And so hopefully like chapter two will have cover some of that, but we also like in the discussion today, we're gonna go through like a few of the case study and exercise to see like sometimes it's not quite easy to map from business metrics to machine learning models. And sometimes we see that machine learning models can do really well, but then if you cannot measure the impact, you might not get the algorithm or the solutions deployed. And you like if you just want to like coast along the Java is fine, but also know that a lot of smart people they want to like get promotions and like be able to do more fun things. And if you can't prove that your work actually show have concrete impact to the company, it's harder to achieve the goal. Okay, so let's get to it.
Yeah. Thank you for that. So yeah, and then we'll be going to the breakout session to have more discussion on the topics you would like. Uh, okay. So in chapter one, we visited basically how AI like has gone mainstream basically right now, and like how more and more companies started to adopt it, how more and more people started to move into ML. And we also saw that like there are huge tech debt among data science teams, and ML algorithm is just tip of the iceberg. There is a lot of things which actually orchestrate your whole ML system in production. So that that whole thing brought misalignment and challenges within the systems. Like ML projects started to fail. We saw like over like from 2016 to right now There were a lot of times people lost jobs because there were like huge friction between business and ML teams. So people started to ask the very next obvious question that what's the recipe to get a successful ML project? So uh, we devised that, okay, let's streamline this whole thing, be clarified within stages, and we moved step by step that, okay, we have project scoping, data engineering, then development, deployment, and like straight away to business analysis. So as let's look at this whole path with an example. So imagine you have a e-com company and you have a business problem which says that, okay, we are going to try to increase the conversion rate of the visitors. We'll try to increase the sign up, like basically the sign up rate, and that would be the business metric. The success criteria in this case we would come up would be that, okay, the new user sign up rate goes up by, let's say, X%. The first assumption we would make would be that, okay, if visitors are going to like the items they are going to see, then they will like automatically sign up for the website, and that's why we are going to like ML team decided to build a recommender system for that. Then the to build that system, there was another assumption we made that, okay, like an item would be that we are clicking on that item, the user will be clicking on that item, so that the ML model would be devised to predict how likely a user will click on that item. So the ML metrics would be precision, recall, and log loss. But eventually, yeah, yeah,
Yes, I
check.
want
Go
to
ahead.
add on the slide is the assumptions of like first of all liking is really hard to measure if someone like an item or not. So like one proxy people use is like you have to make assumption like if people like an item they click on it, but it's not always true. Like you can see the assumption like we can see it's like sometimes people just get an extreme opinion will click on it not because they like it but because they were like what the hell even is this. So we can go through like during the process, we just need to be aware of like what assumptions we are making when we're building the solutions and where can those assumptions go wrong.
Yeah, yeah, exactly. So basically, when we look at the final output, users keep clicking on the recommended items, but the sign up rate is not going up. So we are still asking like, okay, the ML metrics are doing great, but business metrics are not. So what is that which is going on, and what we need to do? So the uh, outcome is that good metrics are not always the good business metric, uh, and we have to reevaluate the assumptions. And if we go back to our assumptions, then we would like to uh, like add more signals to that, like YouTube does. We can add long CTR, like Grubhub does. We can add purchase to rate, and we can even like add a filter where we are like add to cart is equivalent to like an item, and we can revisit the assumption one. If visitor like an item, they like then it is not mandatory, so we could be providing them more incentives to do something the way Medium does. And because of this, we only like figured that, okay, 50% is the only like percentage where ML is going to take us. And so what does all this mean? So the key takeaway is that ML solutions must solve business problems, and success criteria should be dependent on business metrics. If something goes wrong, then we should always go ahead and uh, try to look at what the assumptions we made and how we can tune them. But eventually, like choosing business metrics as well as ML metrics is hard, and that is the key takeaway there. The other key takeaway is that as we saw that we were keep on reiterating the whole process. So it's not a linear thing that we started from one place and we just ended with a very good ML model. It's always iterative and non-linear in nature. There is another example we'll be going ahead with. So recently we saw that ChatGPT like got a huge number of like active users in very short period of time based on the Forbes, and so basically it reached by January 2023 100 million users. What does it mean that the system was scalable? Then in these we like everybody has seen that whenever you ask something to ChatGPT, even GPT-4, there are certain some amount of knowledge, the latest knowledge which is not there. We actually hacked it and adapted it to uh, by providing RAG implementation. So that is like the like one thing we did. The then interesting thing which I found was the jailbreak and the prompt injection which is happening throughout. So even you are like training the model to like withhold some information like PII or something, but there are certain prompts which you can inject, and there are certain ways you can prompt the model, but it will still jailbreak the whole model. So what does all this mean? That ML systems are still failing silently, even with LLMs. ML models are going stale over time, which we saw in chapter 2, but it is still applicable. We can actually go with continual learning with that we can fine tune, but with fine tuning I see that there is a chance that we regress the model from the previous task it was trained on. So these kind of issues are still eminent with the Gen AI uh, like boom as well. So basically what does this mean with respect to the chapter 2 takeaway? Yeah. Yeah, Chip,
To
go ahead.
add that at like the models fail silently, especially with LLMs, because like AI models are just smarter and they are putting themselves smarter, and it's very easy to trick people into believing what they say is true.
Right. Yeah. So moving ahead, so basically, the ML system, the requirements which we had that the ML system should be reliable, scalable, adaptable, and maintainable. That still holds with the uh, like introduction to LLMs, but they have also like evolved over time because the systems which we are dealing right now is like even more complex than the ones we were dealing earlier. Yeah, and now I want to take one more like example or case study. So in 2016, there was report from like cyber crime that we like overall there were like some 200,000 like 300,000 complaints of fraud and ransomware, and people lost over 1.3 billion dollars to these kind of crimes. So Splunk actually took this initiative and tried to tackle it in a this problem in a different way. So what they were trying to do was they were trying to actually map the habits and behaviors of users uh, with respect to how they were using the keyboard or mouse on their website. So basically, what they were trying to do was, as mouse moves on a 2D plane, XY coordinates, and whatever they were getting on the website, they actually plotted it and they created image of how it interacts. And the problem statement basically they were trying to solve was that if a user who is always interacting with that website, the way the way he will be interacting with the website, because it will he will be so used to that like website, his clicks and his mouse movements will be very different from someone who has came for the very first time. So when they actually did that and they formulated the problem statement in this way, it was very unique, first of all. And just with 2000 images for training, they were actually getting validation accuracy of 81%. So, like the takeaway from that particular thing was that if we sometimes have a out of box thinking, we can actually frame the problem in a way that it could give you very like efficient and effective result. I believe they actually patented this whole solution, and like that is what even the chapter 2 talks about, that the way you frame the problem can actually make your development easier or tough. And we have like seen that there is a portability within regression and classification tasks, and how if we decouple the uh, ensemble weights either into like uh, the final scores of the model or something within, then we can move away with the retraining. So that was the takeaway. Yeah, actually, I wanted to have a poll before I move. So just a minute, if I can get the polls.
Yeah, so I think I just want to add why Smith is doing the poll. I want to add on the point of like decoupling objectives. I think in the example in the book is about like, hey, if you want to train the model to like optimize for different things, for example, optimize for like engagements while also like minimizing some kind of like other aspect like enrichment, some people call it that. So I think we should just like need to decouple, and the reason is that sometimes we have different metrics, like first of all maybe like the example of, I'm trying to think of a better example, like DoorDash. So say that you want to order food, and for people that, hey, I want to, the product team want to optimize for people being able to find the right food that they like, and as the sales team want to optimize for, say, the restaurants that like give the most commissions, because you get a percentage of the sales, and like the more expensive restaurants do that. So when you have like different conflicting objective, it's usually useful to like just try to decouple them, and you can try to like give weight to them later. First of all, like, hey, I want you to give this like 60% of the weight and like 40% of the weight, then trying to like combine them both.
I think I'm unable to get this poll up. Maybe Chip, you can try. I can ping you.
Okay. What poll do you want to get up?
Yeah, or maybe I'll try to text you on Discord.
Does anyone so I saw that there are a couple comment here. Shiva, do you wanna jump in?
Yeah, I was in terms of model silently failing. I'm speaking from my personal experience. I have faced this multiple times where feature jobs that are running behind the scenes, they have failed, and we forgot to put alerts on them. And we found out after we had concluded the A/B test and found out that the A/B test itself was wrong because the model was using stale features. So this,
Yeah.
like, model silently failing is a very hard problem to detect if you don't have all the monitoring and observability parts set up.
Yeah, and I think like nowadays we see a lot of people using AI for monitoring. So they try to like as like have AI models, like just look at on the occasionally like look at output and say that, hey, is this like correct? Is this relevant? So actually we have a discussion right now on our Discord on like different metrics. First of all, one metric that people will see is like faithfulness. Like, and people, I'm just like, what exactly does faithfulness here means, right? Because some people think it's like effectuality. Some people think it's like, oh, it's more of like whether it's adhere to what is provided in the context, or like whether it's follow instructions clearly. So, okay, I think I saw the message from Smith. Uh, oh, okay. So the question is, given enough GPUs, can you train an MLM from scratch? Smith, do you want to get some context on the questions?
Yeah, I wanted to have a poll with that, but anyways,
Yeah, but like,
I
what do you want to see? I feel like, okay, given enough GPUs, right, can we train a model from scratch? Is a question of like, should people use train model from scratch, or should they use like existing models? Is that the goal, or what do you want to like get what information you want to get from this question?
Yeah, I just want to know whether if everybody gets enough GPUs because there is a scarcity, then even if we get the GPUs, are you able to like going to train that model? Because I believe that it is not the case given it is very tough. There is a like whole lot of expertise you will require to get that whole like GPU to or the batch of GPUs to like synchronously train on that, like get get that LLM from scratch. So
Yes. So I think if the question is like who can train their own model or like should we even train their own model, I do think it's like I think it's can be like a pretty separate discussions. So I think it's like we have a whole framework of thinking about like, hey, here's my needs and what are usually
hmm,
it could start from like your application requirements. So say like so I think as I mentioned like hard requirements and soft requirements. Like hard requirements is when say it's like more like yes or no questions, and it's just like if a model that doesn't meet the requirement, it just doesn't work. So for example, like I cannot send my data to a third party, so like on the pit API just doesn't work. Or say, hey, I my use case usually require context length of like a million or like 100,000 tokens.
hmm,
So and anything that's like short than that is just make it really hard to work with. So it's just like yes or no questions. And usually if you go or like also another thing is like compute, like I want my model to run on one consumer grade GPU, so maybe like 24 gigabyte. So anything like 33 or like uh, billions param models is just like not gonna work. So these are all the hard requirements, and usually you go through that and you don't find anything that meets the hard requirements, and you might have to train the model from scratch. So I think it's yeah. So I think that's the questions of like whether um it's not just like can you train a model from scratch, but like should you train a model from scratch?
okay, okay, makes
Yeah.
sense.
Oh, okay. Yeah.
Okay,
Oh, I see. So Philip was asking, so the poll was meant to show the bottleneck barrier to entry for training an LLM from scratch is not simple as GPU compute, but you think it's like as a talent and the data needed. Yeah.
yeah, yeah, that makes sense as well. So basically, moving ahead with the like impact of Gen AI, what this is the personal opinion. So I saw that the most impact I saw was on the model development, given we now have APIs. So people actually got like huge access to like all the LLMs and they started to build. So we are seeing more and more applications towards Gen AI LLMs and that has like taken over like the industry. And we are seeing more and more startups coming in just to take up the space. And because of that, we now have fine tuning uh, and model compression techniques, and there are huge innovation which is going on in that space as well. We saw with LoRa, QLoRa, and all the other like quantization techniques. So the other thing which I wanted to actually get out from the pool was that there is a logbook from like OPT 175 billion training from Meta, which shows like how they were actually trying to train for 3 months that model from scratch, and what are the like challenges they faced, and even whatever they trained was not that good, given the whole compute and uh, the whole team. So that was the other thing which I wanted to just share. The other aspect on the side of choosing the ML objectives, because of Gen AI, the evaluation has become very hard. I believe that it has gone very abstract with the tasks like summarization and other things. The other like the big change which I noticed was throughout we were discussing that okay, we should be actually adhering uh, with the ML metric to align with business metric, that okay, there is a business problem that we have to solve. But given the like the rise of Gen AI or the boom of Gen AI, I literally see that people have shifted the whole business to use that tool. So the ideas which are coming now is more aligned with that. Okay, how will I be able to make a business out of Gen AI? So That is one more thing, that the reverse thing which I'm currently seeing. Yeah. And with this, I think I will hand it over to Raghu, who will be talking on the next slides.
Yeah. Thanks, Smith. So I think Smith has nicely explained about the four pillars of machine learning architecture. So the four pillars are like the adaptability, the scalability, the maintainability, and the reliability, all those things. And that stays with classical machine learning, deep learning, and the current generative AI or the Gen AI models. So he explained about the handling the PI data, the masking the PI data and unmasking the PI data as we are sending the prompts to the OpenAI models. And he explained about how the things are working with the current generative AI architectures. So I think now people are doing three things in the current market. So they are inferring the OpenAI models. Some people they are fine tuning, they're down getting the best model and they're fine tuning with their own data sets, and some are developing local models for their specific use case or for their specific task. So coming back to chapter 2, so I think we have covered off many things. So now let's see, okay, what are the different tasks that we are performing with classical machine learnings and what are the new tasks we are performing in the generative AI. So if you'll say the classical machine learnings, we do regression task or we do classification task. Coming to natural language processing, we do topic detection, entity extractions, sentiment analysis, sentence detection, or true casing the sentences so that the entity extractions can happen nicely. So for this, so the future, we need to create the features. That is an explicit task, and we need to choose the correct features. Like suppose we got the training data set, we'll curate the training data set, then we'll create the features. Features like we'll create the unigrams, bigrams, trigrams based upon our use cases, and that may increase the model size and all. So with this classical machine learnings, so generally we do all these kind of tasks with natural language processing taking into consideration. So generally how those kind of things used to do. So coming to the current language models or the LLMs, so generally they work with unstructured data, and with LLMs we do summarization of pulse, summarization of chat. If any of us have used WebEx, if you'll see recently they have added summarize tab, so where they can summarize the content of the charts. And if you'll see they have added a new tab also, like where you can translate or refresh this your chart. So those kind of things now they're doing with the LLM world, and the question answering task also. So coming to this, so now why the LLM models are now a topic of discussion, like what these classical machine learning models are not able to do that this LLM models are able to achieve. So if you'll see, this LLM models are very good at reasoning skills. They know they are good at mathematical skills. So if you'll see, if you are using a RAG-based architecture with a vector database and having a GenAI call, you can automate your applications, or you can achieve.
I think it's one of things I like this like talk about like what LMs can solve that like classical machine learning couldn't solve. So I think there's a it's not a clear cut, right? Because I usually tend to think of them as like closed task, close-ended task, and open-ended task. So close-ended tasks are tasks when you have like very clear set of like answers. For example, like classifications, like you can choose like one out of three classes. Whereas open-ended, like the output can be literally anything. So we have had like open-ended tasks before, like machine translation is not new. But it's just like with today is like we are much like models are much better at that, and the open-ended natures of like models make it very easy to make it work for different tasks. So you could think of like closed-ended tasks as a subset of open-ended tasks, because like when you have a models that can output anything. A lot of people today also use machine like foundation models for like classifications, and there's a whole art of like how to prompt model to output like specified like a specific set of like output. Also people use machine learning model or the foundation models to also try to like do recommender system as well. So recommender system typically we think of it as like a close and a task, but people have been using it a lot for recommender system. But anyway, yeah, sorry, I want to jump in.
Yeah, thanks for jumping in. So you are absolutely correct. So now what people are doing, like they want to automate their applications, the workflows they want to automate. So like if you'll see, suppose you have certain plans, and plans have certain steps, and again certain steps have some prerequisites. So if you want to automate, and in your application you have many number of plans, like if you want to execute certain steps, so what how the correct plan will be get executed. So what you can do, like you can plans have can some examples. You can do create embeddings and store in some vector store using any open AI embedding models, ada or any models. And when you are passing the actual query, the LLM will come into picture. It will pick up the proper plan and the proper steps for you, and it will execute for you, so that all your tasks or in your application or the workflows can be automated inside. So that plan and execute architecture, or the rack based architecture, that people are adopting, and many applications they are now based on this kind of architecture. uh, and they don't want manual intervention now. So if you'll see Devin AI, so that is the first autopilot or the AI engineer. So like that, people are moving into that direction, which were not present in case of the classical machine learning models. That what I understood from the chapter 2. Yeah. So
Yeah,
that's
okay.
all about. Yes.
Yeah. Thank you, Raghu. So I think that's the end. Yeah, thank you, everyone. So basically, we want to thank Chip for these slides which we referred. Actually, we added a couple of slides from a reference that was great. Uh, Andre actually took time and gave us the awesome feedback. I think he is not here, but a huge shout out to him. Group 1 and 10 for their notes, and everybody else. Yeah, thank you so much for being super cool audience. Before I think moving to breakout session, Chip wanted to me to actually share some of my experience, what I went through for from all this back and forth with the slides and the feedbacks and everything. So so basically, I start like we had a very small group. We started with the slides, so I had an understanding with the book club. This is the first time actually I'm participating in a book club. So I read the chapter. I was assuming that okay, we have to present something. That would be summary of the like chapter and what we took from it. But as and when the feedback started to flow in from Chip, like after the second or third round of the iteration, I realized that okay, it is not the case. The actual thing she wanted, like every group or everyone in the book club, was that okay, read the chapter, get the knowledge. Now you do your own research, take some case studies, and see what is still relevant. Because after getting like the book got out, it has been some time. So what is there now? What has changed? How things have like moved forward? That is what like I believed. Yeah.
No, no, appreciate it. I want to say this like, so it's not it's less about what is still relevant. As much as I love people to do free research for me, I don't think that's the goal here. So the goal, I think, there's a format called like flipped classrooms that some professors that I really admire follow. So the idea is that people do their own readings, but so a lot of time people just like do some kind of like just reading and like on autopilot, right? It's just like memorize thing you don't think. So the goal is like how do we get people to do like
Hmm.
critical reading? So we read, but we also think
Right.
about like ask question. Like we read this and we say, okay, is that true? Like how do I verify that it's true? Like and why is that true, so like and what else is missing. So I think it's more like I was hoping that we could go more into like critical reading of anything we read and don't just take things for granted. And the point of like so like the flipped classroom is that people do their reading, people do their thinking, and when we meet in the class we don't go through the material in the textbook, but we go like we do discussion together. So that's what I was hoping with this group.
Right, right. But the way the feedback flowed in, it actually helped me to understand that. And I did the other thing that I went back and then I started to dig into other things that okay, let me find out some use cases where I'm seeing what is still relevant and what has changed. So I think those feedback really helped me to understand okay, uh, like even it helped me to read another book. If I go ahead and read some other book, then it will be like still applicable. So yeah, that was the like good experience I had with this.
Cool. Thank you. Yeah, so thank you. I really appreciate the slides. I know this like it's a little bit hard. So a lot of time people join a book club expecting to just like read the book and not have to present. I just hope this is like by asking everyone to present, we would have a chance to like think more about like what do you really take away from the book. Okay, cool. So I've seen a lot of great discussions on Zoom right now. So I think it's like as a high level, I thought it was like, should we do a group discussion, big group discussion first, or do you want into like a smaller group? As there's also maybe we can do like a big group discussions. I just want you people feel free to jump in. I think like there's one point I want to emphasize is like it can be really hard to link business metrics to like ML metrics. So I would just say just like for example, let's try an exercise, right? So say doing you are a company that do like just sell used car. So you're gonna buy used car from your customers and you resell it. So now you realize on bottleneck people have is it's like people go in and say, hey, I have a car I want to sell to you. And you're like, okay, I'm going to look into the spec like 24 hours on like two business days later, right? And by the time it was like, oh, I already go to another store and they sell it. So like, okay, let's try to build a model to like predict the price of this used car, how much you like as soon as people visit the website, they can enter the specs and you can have a machine model to like tell like how much money they can get from this car. So what business metrics do we want to optimize for this? Do you want to optimize for like say how many cars like we get users to like sell us, or how many cars we can how much revenue? Do you know like what metrics do we use here?
Probably total revenue, right? Because if you can get a smaller amount of cars but make a lot of profit on it, that's more valuable than a bunch of cars that make almost no profit.
Yes. So revenue, right? So now I see like the first metric is like how many cars will sell to us, right? So like let's imagine our models always underestimate the price. Like it was like, hey, overestimate. For every model, it's like here's a car get $100,000. People will just sell it to you, right? But you can't do anything with it. But then for revenue, it's tricky because now not just a machining model contributes to revenue. It could be because you open a new store. It could be because you like do decorations. It could be because you have better salespeople. So like when you have like very high level metrics, like it's really hard to track down what is
Yeah.
important. So I actually had this story quite a bit. So because I usually interview a lot of people for machining role, and they said, "Hey, we built this model," and was like, "Okay, how do you know the model works?" And was like, I should have no idea." So it's come on. So we see that a lot today with especially with chatbot. So I'm not sure remember a year ago when people have a ChatGPT out and everyone's like, hey, let's now build a chatbot to like do customer support or like own the models of like text to SQL or like text to code model. And actually I really enjoyed reading the case studies of companies because the thing is it's like there's this content called like cognitive dissonance. Like imagine you're an engineer or a team lead. You invest a lot of your team energy into building applications. You don't want to admit that it doesn't work. So you could go to retrospective. It's like everyone is like, okay, this worked, this worked, this worked. So it's really hard to find study. Like if you have to dive really deep into understanding like if it didn't work. So first of all, I really like this study. I wouldn't name. But it was about like, oh hey, we launch it and it's generally work, but we turn out it's like people first of all like a text to SQL query. It worked initially because it's novelty, but over time people just like settle for the queries they want. Like because if you use a product for a while, right, people just have like a set of like 10 SQL queries they like to use, and people just use those. So people don't actually use that application anymore. So I really hope to see more of like critical thinking, rigorous experiment on a on like the actual impact of your use cases. Um, Rohan, you want to jump in?
Yeah, like I just want to share like some of my experience with like uh, building some kind of relationship between ML metrics and business metrics. It's like the easiest thing you can do is like if you have like lots of like log data and like historical A/B testing experience, you can actually try to generate this like correlation metrics between your business metrics and ML metrics and see that how they are correlated on a very high level. So for example, like the app we work on, Headspace meditation app, like we can take that example, or Spotify example, that there are certain aspects like increasing diversity in content or novelty in content or like user satisfaction, and sometimes they also like interconnected with each other. So sometimes if you increase like novelty, it might hurt your like user satisfaction, or if you increase your diversity, maybe for the short term it will like hurt some user satisfaction. And overall you can also see that what type of engagement metrics is directly correlated with the your user satisfaction. So if you're seeing that high engagement, like high content start or high content play, is directly correlated with your user satisfaction, you can establish that baseline, like yeah, whenever we improve the uh, engagement, like in certain sense it is reflecting where. But there are like some other ways where we increase like diversity in the content, it hurting like some segment of the user initially, but over the time we see that the long term value is like much positive. So the easier task is to do this like correlation analysis, which can give you like some high level picture. The difficult one is like to use like do the causal analysis, which you need like counterfactual reasoning to understand that if this thing was not happened, what would have it impacted. And you need lots of like log data to gauge that performance. So yeah, that's the one learning I wanted to share. Yeah.
Can I ask a follow-up question? Like, how do you measure user satisfaction?
Yeah, so there are several proxies you can use for user satisfaction. I think everybody has like their own way to do it. Uh, if we are talking about like a very mental health space, a good user satisfaction metrics is like overall happiness of user. But you cannot measure happiness. Like it's very difficult to measure happiness with like implicit signal we can get. Another thing you can do, like if they are regularly doing meditation or like regularly attending the session, that means that like they are actively engaged with the platform. I think for some application like our application, we care about like long-term engagement. So like weekly active usage or weekly active return rate, those are the things are more important. But if you are working for companies, like they care about like short-term engagement, like TikTok or like Reels and all, where you see that like the dwell time or like active time spent within a session is more important. It's all depend like what type of business you have and how closely you understand your business and your mission statement and your like company's priority.
Yeah, I think this is very, very good point. Is Shivam, do you want to jump in?
Yeah, to add to Rohan's point, like in terms of proxies, typical on products, consumer-based products, I've seen time to bounce or number of sessions or like retention type of metrics. And then at my work, we also do time to time customer reviews where we ask how satisfied are you with the platform to get a reality check. I think like it roughly informs us how satisfied customers are, users are with the app and the recommendations and all that.
Yeah, so I also want to say this, like I thought made me think about sometimes like the downside of focusing on all these use case that we can measure is that the story of like people looking for the key under the lamppost because that's the only place we have light to see the key. So we can miss out the use cases where we can potentially have a lot of like impact, but we just don't have a good way to measure the impact. So I also was thinking about is like it's not a coincidence say like recommender systems and fraud detections are like the most popular enterprise use case because I have a clear way to measure the business metrics, right? Like recommender system, like do more click on it, do we have more purchase, and like fraud detection is like how many fraud transaction you stop, like very clear metrics. And also even today like coding seems a bit like so coding is one of those rare use cases when the output is open-ended, but you can evaluate it using like functional correctness. So like you generate a bunch of code, right? And then you can actually use something like unit tests or as a way of like you have test cases to like first make sure that your code compile, and the second you can have very clear outcome, like you see whether code works or not. So I'm not sure if that's the I don't think that's the only reason why coding is popular, but I definitely see this like people could be like see interest in like, hey, it's very clear improvement in the code generations use case. Shall we break into like group now? Yeah. So it's a product I saw someone on the direct message. I'm sure I should read it out. It's a good feedback though. Cool. So let's go into breakout room. So I do think this like I understand this chapter is a bit more abstract on the on the business side. I do think that I wonder if we can do some more exercise. So for example, like think about like the fraud detections, right? Like say, are you all familiar with like how fraud detections work? Like so say like say they do credit card fraud detections. So there are usually three different parties here. So like that's one thing to keep in mind with the use cases. We need to think about all the parties involved. So we have like the bank, and we have the merchant, and we have the users of the credit card. So what happened is like when the users go to a merchant, like a local grocery store to buy stuff, and the person pay with that, and later on, maybe not the user, but like someone who stole the credit card, like stole my credit, and later on I say like, hey, I didn't pay at this grocery store. I want to say I have like dispute, right? And so like the money will return back to me, but the item is already lost. So the question is like, who's losing the money? Who has to pay back? And actually, the bank does not pay back the money. It's a merchant who has to like usually typically pay back the money, and usually you have to like pay what is called like the fraud the I think it's I forgot what is the fee, but it has a fee of like, hey, as a merchant you're responsible for verify if it's like legitimate transaction or not, but you did not, so now you have to both return the money and to pay an extra fee. So merchants, so from the bank perspective, they don't really, it doesn't really matter to them because like they don't lose the money, right? But from the merchant perspective, it's like it's a huge deal to them. So like the bank would do it if they have like complaint from the merchant. It's like, hey, so somehow do a lot of like there's a lot of fraud detection fraud transactions recently. So the bank would like, okay, we're gonna build a fraud detections model to stop the fraud, to like detect the fraud. So what would be the metrics that you think the bank would use to reduce the to measure the effectiveness of their fraud detection algorithm? I hope we only get the question so we can go into the group to discuss. I said Charles raise hand, but let's go into the group so we can discuss the question with the group. Let's just like get a few minutes so that we can go back. Mm. Hey, welcome back. How was the discussion as a breakout? Hey, cool. Yeah, I
Hello.
must. I think we still have a few more groups that have not come back. Cool. Yeah, so I was thinking it's like for next week. Yeah, let's try to give I know so the group 7 is presenting next week, right? I think so, on chapter 3. So chapter 3 is a lot more technical. Actually, I think that chapter 3 is probably the most, at least it was for me to write it. It was the most difficult chapter to write because it's a weird way because right now I'm spending half of my time in AI, half of my time in data system. But back then when I started writing the book, I did not know a lot about data system. And I realized it's like maybe a lot of data scientists. It's weird because like you're data scientist, right? But a lot of data scientists I know also don't really spend a lot of time thinking about data engineering, data systems. So it's a bit more challenging, but I do think it's just very important. Um, so I would say it's like for a lot of data science workload, you might not need to like go really deep into like hey streaming a batch, but the only reason is that it's because somebody else is doing it for you, and usually it causes a lot of frictions between organizations. Because like hey data scientist, I want you to give me CSV5 with that and that and that, and somebody else has to go into their system and usually take like weeks for people just to be able to access the data they want. So actually my dream I see a lot of people are doing is like try to get a way to like make the process automated to reduce the friction. But I also see a lot of pushback from data scientists because this means now that even though they can get access to data faster, now they actually have to do more work. Now they have to know like, oh, we have to use SQL, we have to do joins, we have to like do all of that stuff. So I think that's a very interesting dynamics. So anyway, so I think that's like for the next sessions. If we can, how about we try this format as well? Like maybe we can try to like get more questions in during the week, and maybe we can have more like structure questions we want to discuss. How does that sound? Okay, cool. Thank you, everyone. Thank you so much, Smith and Raghu, and um, Go Gopi, who's not here for the presentations. I know it's tough. I know this like people don't join book club because they want to present, but I hope that we're learning something new. Gonna see you.